Welcome to Topic C1, Particles, the foundation of your GCSE Chemistry course. In this interactive video, we'll explore how the particle model explains the states of matter and trace the fascinating historical journey that led to our modern understanding of the atom. By the end, you'll be able to explain changes of state, calculate subatomic particles, and ace those exam questions. Let's map out the particle model. All matter is made of tiny particles in constant motion. In solids, particles are tightly packed in a regular lattice and vibrate about fixed positions, giving solids a definite shape and volume. In liquids, particles are close but randomly arranged. They have enough energy to slide past each other, so liquids take the shape of their container but have a fixed volume. In gases, particles are widely spaced and move rapidly in all directions, with negligible forces of attraction, so gases have no fixed shape or volume and are easily compressed. Turning to our core study notes, it's crucial to distinguish between physical and chemical changes. A physical change, like melting ice or dissolving sugar, is reversible and no new substances are formed. The particles themselves remain identical, only their arrangement and energy change. In a chemical change, such as burning or rusting, new substances are produced and the change is usually irreversible. Examiners love to test this in multiple choice and short answer questions. Now let's trace the evolution of the atomic model. John Dalton first proposed atoms as solid spheres. J.J. Thomson discovered electrons and suggested that plum pudding model, a positive sphere with negative electrons embedded. Ernest Rutherford's gold foil experiment showed that atoms have a tiny, dense, positive nucleus, leading to the nuclear model. Niels Bohr refined this by placing electrons in fixed energy levels or shells. This historical progression is a common 6-mark question, so remember the key scientists and their contributions. Let's work through a typical exam question. The atomic number tells you the number of protons, here 11. In a neutral atom, electrons equal protons, so also 11. Neutrons are mass number minus atomic number, 23 minus 11 equals 12. If the atom loses one electron, it becomes a positive ion with a 1 plus charge. For sodium, that's Na. Always remember, atomic number equals protons, mass number equals protons plus neutrons. Watch out for common pitfalls. For isotopes, the definition must state same number of protons and a different number of neutrons, just saying same element isn't enough. For ions, remember that losing electrons gives a positive charge, gaining gives negative. And don't confuse physical and chemical changes. If new substances are formed, it's chemical. Examiners also expect you to use the correct terminology, particles not atoms, when talking about states of matter. To wrap up, remember that the particle model explains states of matter through particle arrangement and energy. Distinguish physical from chemical changes. Know how to calculate protons, neutrons, and electrons using atomic and mass numbers. Define isotopes and ions precisely. And recall the key scientists in atomic theory development. Master these concepts, and you'll be well prepared for your GCSE Chemistry exam.